These next couple chapters are going to have concepts in them that will help us solve real-world problems later on. So because of that, our introductions are not going to have that real-world application because a lot of times we won't see these type of problems in a real-world situation. However, we have to understand these concepts in order to solve some pretty high-end application problems later. So let's look at this introduction. Again, basic multiplication problems that we've seen earlier. Simplify 3 times 3 times 3 times 3. We know how to do that. That's just a quick little calculator problem. Actually, a couple different ways we can do that. We understand that 3 times 3 is 9. 3 times 3 is 9. So we know 9 times 9 is 81. Now they say they want us to write that problem as a power. Okay, remember that a power has a base. We understand that we are taking the base of 3 and we are multiplying it by itself 4 times. So we are going to write the exponent of 4. So this is a power that has a base of 3 and an exponent of 4. Understanding that means 3 to the 4th. And if we put that into our calculator, getting some review of that, the 3 caret 4 button is going to give us 81. So we did a good job. Okay, now that we have reviewed those powers, let's look at multiplying powers together. So now they want us to simplify 3 to the 4th times 3 squared. Let's write it as a power and then as a numerical value. Well, let's go ahead and see what this means. We know that 3 to the 4th is 3 times 3 times 3 times 3. They want us to multiply that by 3 squared. 3 times 3. Okay, let's write this as a power. Well, now let's look at what we did. We have 1, 2, 3, 4, 5, 6. We are multiplying 3 6 times. So we are going to have that base of 3 to the power of 6. Okay, let's go ahead and write that as a numerical value. So we know 3 caret 6 is going to be 729. So here is our power. Here is our numerical value. Let's look at what we did. Notice that we took two bases that were the same. We kept the base the same. Let's look at what happened to our exponent. We had a power of 4. We had a power of 2. What did we do to those two numbers? We added them together. So I'm going to say, or what we did was we took our base, we took our powers, we added them together. Is that always the case? Well, let's go ahead and look at one more and see, just to make sure. So they're telling us to simplify 5 squared, which is 5 times 5. And we're going to multiply that by 5 to the 5th. So 5 times itself 5 times. 1, 2, 3, 4, 5 in squared. Okay, write that as a power. We have the factor of 5. We are multiplying it by itself 7 times. So we keep the base, and if you notice, that is actually what we are doing. We are adding those exponents. So instead of having to draw all of that out, now we can understand the rule that I'm going to keep the base and add the exponents. Okay, so we understand that's 5 to the 7th numerical value. 5 to the 7th is 78,125. Okay, is that the same with simplifying bases that are different? So we understand from these two that we can write out a rule, and we're going to do that. When multiplying powers, remember these are called powers, with like bases, keep the base and add exponents. Okay, notice I said keep the base because look at this. Up here, some students are tempted to actually multiply the 3 and the 3 together and make this 9 to the 6. It's not. We keep the base the same and then we add the exponents, and that's going to be our quick answer. So let's look at this one. We are supposed to simplify 3 to the 4th. And we are supposed to multiply that by 5 squared. Okay, so question. Can we do what we did up here? No, we can't, because look at this. When multiplying powers with like bases, these do not have like bases. So can we write this as a different type of power? No, we're going to have to just simplify it back down to 3 to the 4th times 5 squared. Do not write this as 15 to the 6th. It is not the same thing. Let's go ahead and try that, actually. 15 to the 6th. Okay, keep that number in mind. We are supposed to write this as a numerical value. So 3 to the 4th, and we are multiplying that by 5 squared. So what is it? It's actually 2025. Okay, so realizing that we cannot multiply those bases together. For one, we didn't even do that on 3 and 4. So they have to be like bases in order for us to go ahead and use that quick little trick. Okay, with that in mind, and I'm actually going to, I'm going to make that pink, just so we understand that that rule deals with up there. Okay, moving on. Now looking at this one's a little bit different because this is 3 to the 4th, and we're going to take that to the power of 3. Well, we understand that this 4 is telling us to multiply that piece by itself. So I have 3 times 3 times 3 times 3. This is saying take that whole value, take that whole factor times 3. So here's one of those powers. I have to multiply it again, and I have to multiply it again. So I'm multiplying 3 groups of 3 to the 4th. Okay, that's a lot of 3s. Let's go ahead and count them. 4, 8, 12. So all of that together, I have the base of 3. I have an exponent of 12. Okay, let's go ahead and look at that as a numerical value. I'm going to do it 2 different ways. I'm going to go ahead and write 3 to the 12th. And then I'm going to double check that. I'm going to check it with putting those parentheses in and writing it like that. So is 3 to the 4th the same thing, or is 3 to the 12th the same thing as 3 to the 4th to the power of 3? Yes, it is. So it looks like we did it right. 531,441. Okay, let's see what we did. So how did we go from 3 to the 4th to the 3rd to 3 to the 12th? What did we do with these exponents? Well, 4 and 3, in order to make 12, we multiplied them. So with that in mind, let's go ahead and see if that's the same thing down here. Looks like I have 4 to the 3rd, and I have to have 7 groups of that. So I'm going to have a lot of these guys. Okay, again, we are going through this really long step just to make sure we understand the foundation of the rules that we're going to use today. So bear with me as I try to talk and count at the same time. 1, 2, 3, 4, 5, 6, almost there. Okay, well, if you think about back to first and second grade when you talked about groups, if we have 7 groups of 3, how many 4s do we have? Well, groups mean we multiply. So I have 21 4s. So I have a base of 4 to the 21st. And that is why this rule works. So what is 4 to the 21st? Guessing a really big number. Goodness gracious. So notice what this means. This e to the 12th on our calculator means that we're going to take this decimal and move it 12 times. Okay, this is scientific notation. So why don't we actually write it in scientific notation? I really wish that would stay up. 4.3980 46511 times 10 to the 12th. Big number. That's why a lot of times we keep it just as that power. Okay, so what did we find out here? Let's look at how to say this. We took a power and we had a power to a power. Okay, so we are going to say when taking a power to a power again, keep the base and multiply the exponents. So two different rules that we are dealing with here. And once we get into problems, we have to understand what we are working with. Am I taking a power to a power? Or am I multiplying two powers together? They are two different things. So the two different concepts that we are going to learn in this section. So go ahead and get out the notes and vocab for this section. Okay, objective of this section is to apply rules of exponents in numerical expressions with rational exponents to write equivalent expressions with rational exponents. Okay, so again, we see that we have rules, and we actually did just figure out two of those rules. One thing we didn't talk about is this new vocab word, which is monomial. A monomial is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. So basically, mono means one. Nomial means term. Okay, so monomial means one term. Again, it has only one term. In the formula to calculate the horsepower of a car, this is what we have. Notice there is a lot of different concepts going on in there. We're dividing, we're multiplying, we're taking a power, but that is just a monomial because it fits all of this. It's a product. So are we just multiplying all those pieces together? Technically, yes. So that is a monomial. An expression that involves division by a variable is not a monomial. So that is one thing that we have to check. Notice that we are dividing by a variable here, not a monomial. Okay. One other thing that we have talked about before, a constant is a monomial that is a real number. So again, constants. When we look at the number 23, it is constantly going to be 23. That is called a constant. 23x is not a constant. And the reason being is that that can change. We can put a different value in for x and that is going to vary. So this is called a variable. This is a constant. Okay, so a constant is 23. 23x is not. Okay, they do give a couple examples here. We have talked about linear expressions. We know that if we had y equals 3x, that would form a line. If we had y equals 2x squared, that is not going to form a line because of that square up here. So a lot of vocab, a lot of review in there. We're going to look at that here on this example 1. So we are supposed to determine whether each expression is a monomial. We're supposed to write yes or no and explain your reasoning. Okay, 10. Is it a monomial? Is it a number? Okay, yes it is. So we are going to say monomial since it is and I'm going to use the word constant because that is constant, or a number. Okay, let's look at f plus 24. Is that a monomial? Well, it has to be a product of a number or one or more variables. This is not a product, so we are going to say no. And we are going to say it is not a product. As soon as you start adding or subtracting in there, remember, this is a term, that addition makes it now an expression. Okay, h squared, what do we think? Is this a product? Yes, it is, because h squared means h times h. So is this a monomial? Yes. And I think we're supposed to be putting yes, but I like monomial. Monomial, since I'm going to say it has a non-negative integer exponent, which is a very fancy way of saying a positive exponent. Okay, very fancy way. Let's look at J. What do we think? Let's look at all of these different things that it could be. It could be a number. It's not. A variable. It is. Okay. It's not a product, but it could just be a variable. So is J a monomial? Yes, it is. So we are going to say monomial. Why? Since it is a variable. Just by itself. If we said J plus H, No, because we have that addition sign in there. So nice review of vocab. With that in mind, you've got 4 more to do for guided practice. Okay, you should have no for 1A because it is not a product because of the addition. 1B, there is a lot of stuff going on there, but all of it is multiplying. So yes, it is the product of more than one number and variable. 1C, I see division in there, but look at how you can rewrite that. This could be 1/2 times xyz squared, which is a product. So we are going to say yes to 1C, but we are going to say no to 1D because even though we could rewrite this as 1/nth, we're still being divided by a variable. And that was one of the rules that we would have to say no to. So vocab and a lot of it. Let's look at the expressions of a power. We understand this. We understood our base, our exponent, and our factors, but this is a good visual representation if we can't quite remember what goes where. Okay, we also went through this. Okay, again, a nice little visual representation if you need to have that to remind ourselves why we decided we were going to add our exponents. Okay, they show that as what's called the product of powers, multiplying powers. Multiplying powers with like bases. Remember that has to be the same. The base has to be the same in order for us to add those exponents together. So with all of that in mind, let's go ahead and simplify these expressions a little bit different because in the introduction we just dealt with numbers, but we did that to understand the rule. Now we're going to go ahead and apply that. So let's look at how this one's different. We actually have coefficients out here. We have constant numbers that are going to stay the same. So we are going to multiply those two together. So I'm going to have 6 and I'm going to multiply that by 2. Then I'm going to look at my n's. I have n to the 3rd times n to the 7th. Those are the same bases. So I'm going to keep my base because I learned that in my rule, and I'm going to add those exponents together. So understand the difference here. And again, students that go very fast, they want to just add that 6 and 2 together. Since those are coefficients and they are real numbers, we do have to actually multiply. So this piece here ends up as 12 times n to the 10th. Okay, multiply constants and then add exponents of bases. And there is our final answer. So with that in mind, let's look at this next one. Again, I'm going to look at my constants first, my coefficients. There is nothing out here, but technically there is a little 1. So I'm going to multiply those two together. 3 times the understood 1. Then I'm going to look at my p. There's a p and a p to the 3rd. Nothing here, but again, I understand that that's 1. So I'm going to take p. I'm going to add the exponents of 1 plus 3. And now I'm going to look at my teeth. They're terrible colors together, but whatever. All right, so we have t, and I'm adding those exponents, 3 plus 4. So a lot going on, but now we can go ahead and simplify. I have constant coefficient of 3. I have p to the 4th, and I have t to the 7th. And I have a final answer. Kind of looks like what my daughter dresses up in the morning. Many different colors. Okay, so understanding, going through each constant, each variable, combining, and we should be able to get a pretty solid answer. So with that in mind, go ahead and try guided practice 2. Okay, 2A, pretty straightforward. We multiplied our constant coefficients, and then we went ahead and kept our base, and we added our exponents. 2B had many different pieces involved with it. We ended up with a 24. We had r to the 6th, x to the 4th, and t to the 4th. So these do take a little bit of organization in the mind, understanding what am I doing, understanding there is one r here, there is one t here, adding those two together. Some students skip this step, which is okay if you can organize, but I see a lot of t to the 3rds right here, And I see a lot of r to the fifths right here because they forget about that 1. So really make sure that we understand there is a 1 there. Okay, that is called a product of a power. Again, we are multiplying bases, adding exponents. Now we're looking at that power of a power, where we actually have, we're taking a base and we're taking it to a power. We decided that that means that we are going to multiply those exponents. We keep the base, we multiply the exponents. Okay, so now again, organization. When we start getting into some pretty big problems, what are we doing? Are we adding exponents or multiplying? Power to a power, we know we're multiplying. This is a pretty crazy problem because we have 2 to the third squared. Then they're telling us to take that to the power of 4. So let's go ahead and just do this piece first, and then we will deal with that 4. Okay, so they're telling us to take 2 to the third and square it. So we understand that's a power to a power, so we are going to multiply that. So we end up with 2 to the sixth. Whoops, maybe I should do that in a different color. Darn it. And then I lost all of my stuff here. So I'm going to show this as pink because that's what we did right there. And then I'm going to take that and I'm going to multiply that one by 4. So 2 to the 6 times 4 is 2 to the 24th. Okay? Or we could have actually started and understand that that's 2 to the 3 times 2 times 4. All of that together is 2 to the 24th. So power to a power, we know that we are multiplying 2 to the 24th. Okay, 2 different ways to do that. You can do it as 2 steps, or if we understand what we're doing, we can do it as 3 steps. So try that with guided practice 3. Okay, this is a power to a power to a power. So we keep the base, we multiply all 3 powers together. We should end up with 2 to the 16th. Okay, now the fun begins. Now what we're going to do is apply both of those. The product of power, we're going to multiply the bases together, but we're also going to have power to a power inside there as well. So again, we slow down, we understand what it is that we're dealing with. Okay, this is called power of a product. So when we look at this power to a 5 out here, notice what we're doing. And I don't want you to think of this as distributive, but it's kind of the same concept that a lot of times I take that 5 and I know that that power of 5 is affecting all 3 of those pieces. So I do put those arrows in there, not like distributive, but I know that that power of 5 is affecting all 3 of the terms that are, or all 3 of the pieces that are inside that parenthesis. Okay, so think of it that way. Think of it the way that they do right here, where they are, that power of m is affecting both the a and the b. Okay, so let's go ahead and express the area of this circle as a monomial. Okay, that doesn't give us very much to go by, so we have to go back into our geometry world and understand what the area of a circle is. Well, we know the area of a circle is pi radius squared. Okay, we also know that they gave us the radius right here. This is radius. So we're going to go back into our formula and substitute in what we know. We know radius squared. So I'm going to substitute in a 2x y squared. Now what? Now again, I have a power out here and I have more than one product going on in here. So I'm going to have to take this 2, this power of 2, and have it affect all 3 pieces in there. Okay, so we have area equals pi. We have 2 squared. We have x squared. And then we have y squared squared. So there's our power to a power. So y 2 times 2. It's a lot of stuff going on. We are going to simplify that. Anytime that we have a power on a constant base, we do need to simplify that. So I'm going to say area. I'm going to leave out the pi for just a second. 2 squared is 4. Then we have x squared. 2 times 2 is to the 4th. Then I'm going to put the pi. Pi is an actual number. A lot of times we like to see that at the end. So again, when you have that power, when you have that parentheses, that power is affecting all pieces. We do simplify our constant coefficients. and that should be our final answer. Okay, so again, keep that in mind. This is geometry, so make sure we understand all of our formulas and how to substitute in what we know and what to do from there. Okay, try guided practice 4. Okay, anytime you're dealing with formulas, write that formula down and then figure out what we know. So the area of a square is side squared. They tell us the side. So then I take that formula, I substitute in what I know. I realize this is, again, we have to do that power of a product. So that square is affecting all three pieces. And then I simplified that down. 3 squared is 9. And then 2 times 2 on my y is y to the 4th. I like 4b because looking at the area of a triangle as 1/2 base times height, I know my pieces. I plug it into my formula and I realize that this isn't a power of a product. This is actually a product of powers. And I know that all of those vocab are weird, but what that is saying is that I understand now I am just multiplying. There are no powers involved here. So I plug in all of my pieces. I know I have to multiply that 5 and 4 together. I know I have an a times an a, which means I'm adding those exponents. I have nothing to combine with my b squared, so he just hangs out here at the end. I have 1/2 of 5 times 4, which is 10. I added my exponents together, and then I brought that b squared along for the ride. Okay, so again, write that formula. Plug in what you know. Try to figure out what it is I'm doing. I'm adding exponents here instead of multiplying. Okay, now we're going to see what this is all about. We are going to combine all of these properties together, and we are going to simplify some pretty high-level type of problems. Simplifying expressions, here's the rules. Each variable base appears exactly once, so we can't have more than one x. There are no powers of powers, so we don't have x squared to the 4th, and all fractions are in simplest form. Okay, so as long as all three of those are there, then we should be good to go. Look at this problem. Man, there's a lot going on. So the very first thing that I'm going to do is I'm going to rewrite each of those pieces over to the side so I have room to work. And I am going to color code them because I'm going to focus on one piece first, then I'm going to look at the other piece, then I'm going to combine. Probably the best way to do this. So I'm going to simplify 3xy to the 4th squared. Then I'm going to simplify negative 2y squared to the 3rd. Okay, first thing that I see these parentheses, I see a power of 2 out front, so I know that that 2 affects all three pieces. So that gives me a 3 squared, an x squared, and a y to a power, which means I'm multiplying. Power to a power, multiply. Then I have to simplify this down. I have 9 x squared y to the 8th. One piece done. Now I'm going to focus on the second piece. Again, power to a power. I'm actually going to rewrite this because I see a power to a power right away. So I realize that that's negative 2y to the 2 times 3, which is negative 2y to the 6th. Then I see the parentheses. I realize that that 6 affects both of these. Okay, negative 2 to the 6th, y to the 6th. Look at what I did there. I put parentheses around this, and here's a huge deal. And I'm going to stop and explain this right now because, man, do we see a lot of frustration when we look at this. Okay, this is saying take the quantity of negative 2 and take it to the power of 6. That is what this problem is telling us. So negative 2 to the 6th is 64. Look at what happens when I do not put those parentheses in there. If I say take negative 2 and take it to the power of 6, what this calculator is doing is it is taking 2 to the 6th, which is 64. Then it's taking the opposite of that value. Okay? The answer to negative 2 to the 6th is not negative 64. It is a positive 64 because what we are doing is we are taking negative 2 times negative 2 times negative 2 6 times. When you do that, it comes out positive. So please really focus on plugging in negative powers with those parentheses around it so we don't end up with a negative that should not be there. and then we have y to the 6th. Okay, so we have both pieces done. I'm going to bring down this 9x squared y to the 8th because I'm taking this and I'm multiplying it by this. So I'm not even done yet. Okay, I'm going to take these two pieces and I'm going to multiply them together. So what do I get? I get 9 times 64. I get x squared with nothing to multiply by, and I get y. Okay, I'm multiplying my bases, which means I am adding exponents. So what is my final answer? Well, let's find this out. 9 times 64, 576. Okay, we have 576 x squared y to the 14th. Wow, many, many steps. But I would recommend simplifying each piece together, then combining those two pieces. So we did it. All variables show up once. There's no powers of the power, okay, which would be this right here. We don't have that, and we do not have any fractions. So we are good to go. Okay, another fun looking problem. So go ahead and try those steps on guided practice 5. And there it is. Okay, that power of 3 affects all of these. When we look at fractions, this is saying 1 to the 3rd. So technically this 3 is affecting both the numerator and the denominator. So 1 to the 3rd is 1. 2 to the 3rd is 8. And then we multiplied. We ended up with 1/8, a to the 6th, b to the 6th. Second piece, we saw that that power to a power was 2 times 2, which was 4. That 4 then affects both pieces. Notice what I did here with the parentheses. -4 to the 4th is a positive 256, b to the 4th. I have my two pieces. I know I'm multiplying them. So I multiplied my constant coefficients together. I had nothing to multiply with my a. I understand multiplying bases means adds exponent. So final answer, 32, a to the 6th, b to the 10th. These problems take a little bit of time, so you might as well slow down and make sure you get the correct answer at the end. Okay, go ahead and try the assignment for this section.